first, part one, since I have not seen you for a while, let's call this a recap. I gotta jump back into where I should be in chapter 3 here. Guys, by the way, the homework schedule, Lisa, I thought about you. Make sure when you do the homework, and I'll let you know which sections I'm going to check. Do sections there. I know, don't go by the day there. Find the section that we're covering here and go by the section numbers for that homework. Guys, first thing we'll point out is, here we go. Part one, recap. I like to solve this absolute value. Let's see, where am I going to start? Yes, 3x subtract 7 less than 8. Now, I give you a nice handout, so you got first go to the handout. There's only 2 rules to follow in most cases. This one looks like it fits this rule, and I think the rule is written up like this on your handout. Which means if it fits that rule there, try this. Try to place u between negative a and positive a. If it fits. Looks like the black inequality, absolute value inequality fits that. So guys, I can picture you say, well, this means negative 8 less than 3x subtract 7 less than 8. This rule here. And then try to solve it. Now this one's not too bad to solve it. I'm going to add 7. I'll actually show all the steps here. So we end up with a negative 1 less than, the 7's cancel, of course, 3x. This one's not bad at all, 15. Divide by 3, guys, if I divide by 3, and I'll actually show that here since I'm right on top of the problem here, you're going to end up with a negative 1/3 less than x less than 5. Basic arithmetic there. And that's the answer. Now if I say express that answer using interval notation, it says you're caught between negative 1/3 and 5. So I may say also express this using interval notation, you're done. Now I wish I could stand here and say all inequalities, absolute value inequalities, were this easy. Some are tricky. My 4 o'clock session saw some that were a little tricky here. In fact, I may have one of those handout, not this handout, in my notes to point out. And we'll try part B there for another point here on this. Something else to point out. Guys, the next one looks like this. Absolute value, 2x squared plus x is greater than negative 5. Here's the catch. I might think as a student, you would say, Professor, there's only 2 rules to follow. It looks like, at a quick glance, it looks like this. Absolute value of u is greater than a, which means, you gotta know the rules here, x is less than negative a, or x is greater than a. That's what it looks like. It looks like it takes that form. But something crazy is going on this one. Anyone take a look at the way I presented this, the way it looks? What's a little bit different about this one where maybe a rule is not really needed? Lisa?
We can simplify write as the quadratic equation.
Tell me more.
Move negative 5 to the left.
That's what I'm saying. That's why these can be tricky. I understood what you said.
Mm-hmm.
Something else obvious, if you've really got your mind set on what absolute value means, it's pretty obvious here. Professor, you don't need a rule to follow. There's something strange about this problem. Now I see some hands going up. Darian.
Because the absolute value is always going to be positive.
this will always give you, for absolute value, if you see absolute value bars, that means the answer will come out to be a positive, could be a 0. So the result is a positive or 0. Now, please, are all positive numbers greater than -5?
Yes.
Is even 0 greater than -5? What's that tell me immediately? What's my answer? All real numbers. Here's my solution. For you guys who like the script R, you're done. No rule to be applied here. So you gotta be very, very, very careful the way it's presented to you. Before I leave it, can someone do me right quickly? Now this one's finished. If it had been this, now that's no solution. There's no positive number less than -5, and definitely 0 is not less than -5. So that'd be a no solution. Just in case it had happened like that. Now with that said, we got that one out of the way. Letter C. I threw one more in, I think I did here. I did. Try to find it here. Oh, good. If I saw this, here goes guys, absolute value, 8x subtract 3, is greater than 4. I'm trying to make it real simple there. This one, if you take a close look at it, I'll put the rule here that I think we can use. It's this rule. And it means, as you have seen before, that this means u is less than -a or u is greater than a. It's like this one up here. In fact, it's u up here rather than x. I placed an x for the problem here, u. There's the rule to follow. Guys, if I follow this one, I don't see anything different about this one. I don't have to pay much attention to it. It looks like it directly follows the rule. This quickly tells me on the side here, 8x subtract 3 is less than -4, or 8x subtract 3 is greater than 4. You guys agree with that? Is that what it means? If I drop the absolute value bars? Now if I try to solve this one, guys, this is 8x is less than -1, x is less than -1/8. Watch my math there. The other one, if I try to solve it, I end up with 8x is greater than 7, looks like, or x is greater than 7/8. So let me step back and make sure all that looks good. Do we agree? I did it quickly. That's the answer. Now, how's that look in interval notation, which I'll ask you to do? X is less than -1/8 means this, a -infinity up to a -1/8 union, the other piece, 7/8 through infinity. And there's your answer. Done. Now that's a quick recap of what was going on last week with the absolute values. Now, do I have a challenge for them on this quiz like I had on the last 2 quizzes? I do. I'll have a challenge type on this quiz also. Any concerns here? Just be extra careful. Kyle.
For A, it's the lower bound is positive 1/3.
Was there a positive 1/3? Because I did it quickly here.
Is that a 7 or a 9?
Which one?
3x minus,
That's 3x minus 7.
sorry, that's my bad.
You got it?
Yeah.
Okay. Guys, anything else on this? That's just a quick recap on absolute values. Now, it's going to lead me back into chapter 3 where I should be. Try to get this chapter 3, most of it done tonight. Part 2, sketch. You're also responsible for this. Wednesday. Sketch a nice polynomial function for me. And the 4 o'clock session, we had some nice ones there to look at. Guys, let me see what I did here with this. Here we go. First, let me point out, before I jump directly into it, if you were asked to sketch this, guys, I'm gonna start with something fairly easy. P of x is equal to x cubed, subtract 2x squared, subtract 3x. Now, I guarantee you when I jump into this, some of my students are alert, they're on it. They're probably going to be thinking about sign analysis to be used, whether the graph is above or below the x-axis to get the graph. More than likely on the quiz, I'll have in the directions use my methods we've seen just recently, like in behavior, zeros, touch, cross. And if you have a little time, we'll read through it by sign analysis to see if it checks. That's good. So guys, we'll do this. With what you see here, I'm going to first start out with, right now, before I go to the grid, please discuss this. What is my graph doing on the ends, called the end behavior, even before I see the graph? And I'll have this typed up for you. Got 2 questions to be answered. One question, I think I used some notation. I think one question was from calculus, they want you to find what? The limit? As x gets large on this function, they want to know what is it doing. And the other question is, find the limit as x is approaching negative infinity of this function. That. I'll have that typed up and you have to answer those 2 questions for me. Now how am I going to answer those 2 questions? I'm going to take into consideration what this thing says in the red. It says make x large. X is approaching infinity. Guys, if I make x large, that does not mean you go back and put a large number in each one of these. That's too much. Can anyone tell me, if I'm using in behavior, what should my graph behave like? Therefore, I need not take a look at the entire function. I just need to take a look at one specific part, and that part is?
The degree, since it's 3.
I got you, something else. To answer the in behavior, what part of that trinomial should I look at? I don't have to look at all of it to answer the in behavior. There's only one part that I have to look at. Yes, sir?
X is positive or negative.
Something else. If they ask you for in behavior, what's my graph doing on the ends? It all depends upon one part of that polynomial. If this thing had 6 terms, you need to look at only one to answer in behavior. 8 terms, you need to look at only one of the 8. What term should I look at of the 3 to help me determine what is my graph doing on the ends? Yes? The first term. You just bring the first term out, and I will do it right here on the side here. So you'll see it. This is what you're looking at, the first term, to answer those 2 questions. And by the way, you guys remember parent graphs? This is like x cubed. What's x cubed doing? My graph should be doing the same as x cubed was doing on the ends. To answer these 2 questions, guys, translation in the calculus, you're making x large. You're replacing x by a large number, and it's a positive infinity, like a positive 500. Like you substitute 500 in there, and then you cube it. What happens if you cube 500? Does it get larger?
Yeah.
And then if it says x is approaching infinity, you say maybe 500, let's go a little higher, Professor. How about 10,000? If you put a 10,000 in there, which is a positive, they want positive infinity. You cube that, does that even get larger? So it makes sense that this result is, if I think about it correctly here, this is giving me large answers, large numbers. It's approaching infinity. Now be careful down here. This says now try negative. In fact, small numbers like negative 500. If you put a negative 500 in here and cube it, you get a negative, of course. If I put a negative 10,000, you cube it, you'll get negative some number. What do you think that implies is happening here? Negative infinity. That tells me when I finally get to the grid, what's happening on the ends. I'll show you what that is when I finally get to the grid, but that's the end behavior. Number 2, I will ask you to please quickly identify the zeros for me. Now, the problem is the original function is not factored for you. I'm looking for the zeros. So guys, I'm going to jump back up to the function. I'm gonna take out a common factor of x. Do not let me make a mistake. And please tell me, does it look like that?
Yeah.
Yeah,
Then it factors further. I think into x subtract 3 times what? X plus 1. Now, can you tell me from the factored form up here, you split those up, consider each factor, z equal to 0, what are my so-called zeros coming out look like? Yes?
It's gonna be 0,
0,
3, and -1,
3, and
-1.
-1. Now, put on the side here, those all will also be my x-intercepts when I get to the grid. So those zeros will act as x-intercepts when I get to the graph. Jeez. Just out of curiosity, which would help, I'll probably ask you to find also the y-intercept right quickly, which is not too exciting on this one. To find it, you go back to your function, replace all the x's by 0, in other words, p of 0, and I think in this case, guys, replacing all those x's by 0, you get 0.
yeah.
So I think I have enough to get a rough sketch of this graph without sign analysis, based on what I see here. Okay, guys, so let's see what this looks like. And it may look like, if I can get all this together. Right. Now let's see what it does look like here. Mind you have one of these on the quiz. Guys, I'm going to first plot my zeros, my x-intercepts. I got 0. I have 3. What to 3? I got this as an x-intercept. I have a 3 as an x-intercept, and also a -1 as an x-intercept. Also, the y-intercept in this case is 0, so I have it already done. Now let's jump up to the red and get that end behavior out of the way. On the right,
Yeah.
as x is approaching infinity, out here. On this end, it should be
Positive.
rising.
Yeah,
So this, guys, will give me, I'll do it like this. It should be doing something like that. I make a little curve to it. These are curved. On the other end, negative infinity. That means you're out here. The result was what? Also negative infinity. Means out here, on this end, it's dropping. Now what's happening in between? That all is determined by, and someone's going to have to remind me, how does one now finish up? No sign analysis, unless you want to take the time to do sign analysis. Who recalls now what can I do fairly quickly and get a rough sketch, and behavior's done, from there? Yes?
It's a power of 1 and it crosses.
Thank you. Go back to the factored form. You tell me, Professor, you got to look at the exponents on each one of those factors. I've looked out here. They're all odd. One's an odd number. What happens if the exponents on those factors are odd? What does that tell you about the graph?
Touching.
Oh, see, those weekends are killing us. What does it tell you if it's odd? I mean, one word.
Touching.
One word. It's going to cross. It's going to cross at each one of those x-intercepts. So that means, Aiden, you and I were talking about this. Here's -1. I've already determined that all 3 of my x-intercepts, it should cross. So that means I'm putting it right here. Oh, I'll put it in a different color. It should cross. Now, when it does cross the x-axis, it goes up above it. It's got to come back eventually and pick up 0. How far up it goes, I don't know. I don't know myself. Unless I do a little calculus. Now I'm at 0, going from left to right. Well, we determined all of them. Down here, all these came from odd factors up there. So guys, that means it's going to cross again. How far down it goes, I don't know. But it's eventually got to turn and come back and pick up 3. And by the way, at 3, does it now cross also at 3? Does it cross the x-axis from below to above? And that is a rough sketch of this. Done. So you got touch, cross, I didn't have any touch on this one. Touch, cross, in behavior, you got it done. Now you guys, you got a little time on Wednesday. Some of my students finish up the quizzes fairly quickly. So if you do finish up fairly quickly and you got some little time on your hands, you could sign analysis, sign analysis, sign analysis, sign analysis on this thing for a check. Can you guys take a close look? This look pretty good? All that? Now, let me check. See how my notes are here. Oh, I do have one more. Jeez. Here goes. Before I leave it. On the side here, guys, let's call this part D. For a reason. P of X is equal to this. Negative 1/2 X plus 4 X subtract 1 squared. And I gave you this one in factored form to begin with. I'd like to know what does that look like, and if you see this little process and work with it and practice with it, the process is easy to get a sketch of these things. Guys, the end behavior, let me get that out of the way first. And you have to answer these two questions for me. Gotta be careful myself on this one. Limit as x is approaching infinity of this function. And also we have to answer this question. Find the limit as x is approaching negative infinity of this function. I'm gonna get that out of the way first, right now. Now remind me, what does that depend upon?
First term.
The very first term. Now, I did not multiply this out for you. Be careful. Now, I'm not going to ask you to expand this thing out fully. But can anyone tell me, back here it's easy to see, the first term is x cubed. This one, can anyone tell me, without multiplying all of it out, what on earth would just the first term in this expansion look like? Because I need to look at it. Yes? I need more. The full first term would look like what in this one area?
Negative 1/2 x cubed.
Negative 1/2 x cubed, which will play a part. That's your first term. That's what this graph is going to resemble. Now I can answer those two questions. As I make x get large, guys, if I replace x by large numbers and cube them, they get larger. Positive, don't they? But then multiplied by what?
Negative.
Negative. What is that final result if you have to multiply that by negative? Is it a negative one, a negative infinity?
Negative infinity.
Next one says now replace x by a negative number, like a negative 500. The negative 500 cubed is going to be a negative result. But then times a negative 1/2 out front, we'll change it into a what type of result? Positive infinity. That first term is all you need to look at. So when I finally get to the grid, that tells me what's happening on the ends of this graph. Next, and I'll have this written like this on the quiz. You need to identify for me the zeros. So here goes. Zeros are, if you split the factors up, I see a negative 4 coming out. And I also see a 1 coming out. You guys agree? A negative 4 and a positive 1. Is that true? Those are my zeros. Now, can someone tell me, how many zeros would you expect this function to have altogether without fully expanding? 3. With the highest exponent, the degree be 3. So I should have 3 zeros. I've only listed 2.
That would be one multiplicity.
Thank you, Lisa. So you got to show 1 is a multiple answer. It's a multiplicity of what? 2. That's acting as two of the answers, two of the zeros. And of course, this one's all by itself, negative 4 is 1, then it counts down for 3 zeros. I got negative 4, comma, 1, 1. Negative 4, comma, 1, 1. Multiple answer.
Do we have to write that down on our test?
Yes. If there's a multiple answer, I'll be asking you to write the multiplicity. Now tell me before I get to the grid. Can someone tell me, even before I get to the grid, when I finally reach negative 4, should my graph be touching or crossing the x-axis based on what you see up here? I'll just put the word touch or cross, so I'll be aware of it even before I get to the grid. Samantha. Negative 4 came from this factor here, guys. She's telling me, Professor, on the outside, I understood to be a 1. Odd. So that should be crossing here. No problem. The 1, oh, the 1's nice. The 1 came from this one, this factor. On the outside's an even exponent. If it's even, it should do what?
Touch.
Touch. I know all this before I even get to the grid. About this graph. You can almost visualize in your mind what the graph's going to look like. There's all that detail. Let's see what it does look like. And let's look at this. You guys, I'm going to get my zeros on here. Just a couple of zeros here. Negative 4. I'll just put it down here. And a 1. So I have an x-intercept here, an x-intercept here. In behavior, I think we determined, here goes, in behavior on the right, as x is getting large, on the right-hand side there, we determined it's doing what? Dropping, negative infinity. So does that tell me out here, is it dropping down like this, yes or no?
Yes.
At the other, as x is approaching negative infinity, you're going this way. It came out to be this, when we checked the first term, positive. That's what it's doing on the ends. Okay. Now, touch cross, let's see what happens here. Guys, as I look at negative 4, we've already said it crosses, so I will go ahead and cross over if you don't mind. By the way, the y-intercept may help also. I'll probably be asking for the y-intercept. Is there a y-intercept on this one that will help me somewhat? Let me throw it in. Y-intercept might be needed. I need to find p of 0. If I put a 0 in up there, I got negative 1/2. 4, you're not going to make a mistake. And I think you end up with a 1. Replacing x by 0 and doing the math.
That's negative.
Is that negative 2?
Negative 1. Or no.
Is it negative 2?
It's negative 2.
Negative 2, isn't it? I think. So that tells me, which might help me, there's a y-intercept down here at negative 2. So let's go back to a negative 4. We determined that negative 4 is supposed to, I think we said cross, it's going to cross over. So guys, it's coming down like this. It's crossed over. It's supposed to come down though and eventually pick up this. May do something like that. Pick up that y-intercept. Come back up to pick up the 1. And at 1, I think we determined earlier, is supposed to just what, touch and go back down. That's a pretty good sketch of this. That's this picture. If we have no mistake. Lord, let's hope we don't have a mistake. Look pretty good? Samantha?
Just like for the end behavior, in this problem, if it's like it's negative half x cubed, and that just like you can also just consider as a function.
Yeah, that negative 1/2 is what throws students off. That negative 1/2 is part of that response.
Well, it's
Yeah, because I had a student first, I can understand too. I had a student first to say, the first term looks like this, Professor, I agree with that. But you probably just focused on that x cubed. No, you also have to focus on the negative 1/2, the entire first term.
But because it's a negative, can't that be considered a reflection?
Yes. Who said that? Samantha, yes, if it's a negative, like a reflection, okay? But that negative one half plays a part, guys, be careful. Now that, I think, also usually takes about half an hour to do a recap. I think that's pretty good. You guys appreciate these recaps? Woo. I used to just walk into class and start on the new material. No, I can't do that now. No, I need a recap myself. Okay. Guys, any concerns here? This is your quiz. These are 2 topics for your quiz. Now you know how Ramsey is, all of a sudden you get your quiz back, you got 6 out of 10. Or 5 out of 10. He said, Professor, but you told me absolute value. I placed an absolute value on there. It may not be the easiest absolute value in the world, but there's one on there. Now I may ask you to sketch a graph. Let's hope it's something like these, but it'll be a polynomial function that you gotta deal with. Yes?
It's the relative synthetic.
Oh, we're going there now. Not on the quiz, not on the quiz.
Okay.
No. No, all that business is coming up next week for a 2.5 hour exam. I want to give you an extra time for the exam, not quiz. For the exam next Wednesday, usually 2 hours. No. I think it's gonna take 2.5. Wait till you see what that exam covers. Wait till you see the reviews you're gonna pick up on Wednesday this week. Guys, I think we did a pretty good job on this. Wait, whoa. I know I get carried away. Can anyone tell me, extra credit, type problem. Can anyone tell me, I think this was for this, wasn't it? No, over here. Suppose I ask you to do this to it. It's called f of x. Now, sketch that. I'm just getting you ready for calculus. Some of the students are crying already for calculus. Oh, this is for preparation for calc. Now I want the absolute value, I want a graph of the absolute value of this function, which means I want the absolute value of this graph. Easily done. Who would like to volunteer and come up and show us what change would you make in this graph to show me? Now, the professor wants a graph of the absolute value of that function. Would someone like to come up and make, Lisa, come on up. My dear, here goes, use the green and show us a few little changes.
So that would be reflection across y-axis.
Oh, you don't have to do that. Easier than that. It is a reflection. Go ahead. Don't make anything hard out of it. It's tricky. I'll give you a hint. What does absolute value mean?
That would be positive.
Now, that tells you in the class. You have better show me a simple adjustment to this graph to show it better be positive. In other words, all of it should be above the x-axis. Now, what are you going to do to adjust it so those parts that are below should not be below for absolute value, they should be above. Show the adjustment.
So, does it mean so it will be?
No, that part's good. We're gonna leave that part there, that's above. That's part of the answer. Now what are you gonna do to this part here that's below, it can't stay there. What are you gonna
Minus
do?
that becomes 2.
That would be just one half cubed.
You're thinking too hard. Thinking way too hard.
Professor, may I attempt?
Oh, here we go, I see more hands going up. A little simple adjustment, but as a student, I'm thinking about Lisa too. As a student, I'd be thinking, whoa, what do you want here? I'm getting too stupid. No, it's not that difficult. That's what happens in math, something simple, and all of a sudden you try to make something difficult out of it. Samantha, come on up. Now, we're gonna leave this where it is.
Well, in general, the parent function of an absolute value would be like this, above the x-axis. So in order to get this, you have to have this be like this.
Thank you. Don't make it a curve, make it a curve. Don't go straight line. Okay.
And then you gotta get the -2 so you can just reflect it. So what you can do in this case is you find the absolute value of these.
Okay, so she's gonna move, this is what, -2? Now it's up here
Positive
2, positive 2.
So I'll say here.
Okay.
Can I like redraw it?
Now, what are you gonna do with this part here? Get stay here.
Yeah, so because like using our rules that we use the end behavior, or sorry, with going through and touching, so what it would do is it flip because the absolute value, like it I don't know, in my mind it just like makes sense, I guess.
You guys are making such hard,
Wouldn't
what
it
she
just
said
go
is
like-
correct. You're making something so hard out of something so simple. And that's what math is. Every time you see a math problem, you think it's gonna be hard. Many students think math is hard for me, professor. You're making it hard. I used to do the same thing. You're making it hard. I need one more volunteer to come up. There's one more little piece here to this graph. Guys, this stays where it is. She took this piece right here up here. This stays where it is. Now tell me, what are you gonna do with this?
I'm gonna take this part here, basically, is this,
Got you.
and this part here does this, and this stays the same.
There you go.
Thank you.
There you go. That's all I need to see. Let me put the green here. I think Lisa did this for me. You got that piece guy there? Then he said, wait, professor, you gotta take this little piece down here, flip it over. This should be above the x-axis. Is that true? Does that look, there's the purple, and he took it into the green, he just flipped it over. Make sense? It's above the x-axis now. And then Samantha, you took this piece here and made it look like that. You flipped it over the x-axis. Please tell me, is everything now above the x-axis? The green. That's the graph of absolute value of P of N. That's what I have for an extra credit. Now, since I've already done that, I've got to come up with another extra credit. Does that make sense, guys? Students came up and trying to make something hard out of it. You have to flip that thing and make sure everything's above the x-axis. That's what absolute value means. It's positive, so it's got to be above the x-axis, the entire graph. If it's not there, you got to flip it over or reflect it, like I heard Samantha use the word reflect. You got to reflect it over the x-axis. Okay, Lisa, quickly.
So why is still the -4, the graph still will be positive? Is that because of the?
Are you talking about this -2?
No, -4.
-4 stays right where it is because absolute value -4. That's at 0. It stays at 0.
It's just because it crosses the.
Yeah. Is that true?
No, like I'm asking.
This
why-
piece right here was above the x-axis to begin with.
So it's still above, so we don't need to change.
No. What?
I thought we need to reflect all the whole graph.
We're reflecting the graph at -4, you're at 0, right? What's the absolute value of 0?
0.
It stays right where it is.
Okay, makes sense.
Does that make sense now?
Yeah.
You guys agree? Is that the graph? If I ask you to find the absolute value, yes, go for it.
So technically this graph is not an x cubed graph anymore.
Oh, the absolute value graph. Turns in, no, thank you. Not after I take the absolute value. Oh, by the way, does the absolute value, and I think Samantha was pointing this out. She said, Professor, I remember the absolute value takes like a V shape. Is it this one even taking like a V shape somewhat? Out on the edges? She sort of had that in mind also. Guys, if you're trying to make something hard out of that, you said flip over, make sure everything's above, on top of the x-axis. If you see absolute value. Needs to be done. Now, with that said,
Wait,
geez,
I have a question.
I love the discussion, so, yeah.
So with absolute value, it's gonna make a multiplicity at -4.
Ah, beautiful, beautiful, beautiful. We're going to have -4 as a multiple answer,
Okay.
even for the absolute value.
Okay.
Whew. Okay. Nice, 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 nice. Now, guys, the next part we'll jump into, and I got a handout here for you guys. I wrote myself a note here, if I can find all my notes today. Here they are. Here we go. We'll start with this one. Now we're into, now the graphs are done. We know how to sketch a graph, in behavior, zeros, touch, cross, and all that business. Now, the ending, the closing down to chapter 3, almost closing down. I'm gonna move into, forgot what parts I'm in, part 3, I think it is. You guys can remind me. I gotta do this. Find this. Find the zeros of this. Here. Here we go, chapter 3 is going to be finished up in no time except for one topic after tonight. Find the zeros. And then we're going to sketch it. Now I brought in, and we may have had a chance to look at this last week, I can't recall. The P of X by function is this. Aiden, I think you and I may have looked at this one. Guy, remind me, did we?
We did something like that.
Something like that.
We did something.
We may have done something like that in class last week.
Yeah. we did something.
Okay, here's some questions. How many zeros must I get? 3. That means on your knockout exam next week, if you see a 6, you gotta get 6 zeros. If you see an 8, you gotta walk out of here and have 8 zeros. Some of them may repeat, some may be multiple answers, but you have to account for, in this case, 3 zeros. Guys, to find the zeros of a polynomial function, first thing you're gonna do in your mind probably say, well, professor said equal to 0. And if I said find the zeros, what do you think I'm implying? Just find the real? Or do you think I'm implying find complex, which means all zeros? So if I just say find the zeros, that means find all of them. So if I see an I coming in, I'll accept it. Okay, guys, here goes. First thing we'll do on this one, I think what you would do is group and make it in factored form, look like this. In my first grouping, take out a common factor of x squared, and do not let me mess up here. On the last two, pull out a negative, like a -1, and you have that left over, which is cute. Now you've created a 4x minus 1 in both, so take that out. You could have it expressed at this point like this. Take out that common factor of 4x minus 1, you're left with x squared minus 1. I'll put the x squared minus 1 first. That x squared minus 1 now will factor further, difference of squares. And guys, here goes, and this chapter 3, to me as a professor, what we're doing now is, I think, the best part. The most interesting part. There they are. You said, professor, you said solve it. Oh my goodness. Can I now split these up and set each factor equal to 0? I think. And solve right quickly and get a 1, a -1, a 1/4. Those are my 3 zeros. You're hoping to see one like that on the exam. That's what you're hoping for. And quickly say, professor, my goodness, give me more of these. This one's easy. 1, -1. I don't care what order you place these. 1/4. You're done. Not quite. Those are the zeros. I agree with that. But you're not quite done. So that's part 1 of the problem. Now we're using a different color. Can someone now tell me, based on this, we factored this, I think, right? So the factored form, put it right above it. came out to be, we factored by grouping, came out to be this mess, x minus 1, x plus 1, and 4x minus 1. Let me just repeat it there so I can see it. There's the factored version. Those are my zeros. Now, let's tie it in with the previous lesson. Now, I'd like to sketch this function. I'd like to sketch the function and have everything on the same paper here, on the same problem. Here we go, guys, making a connection here, go to my sketch. Quickly, my zeros are, I have them listed, and those are my x-intercepts. I got 1 here, got a -1 down here, place it here. I got a 1/4. Oh, interesting. Got a 1/4 right in here. Squeeze in 1/4. I'm rounding up the word, guys. I don't want to make a mistake. Whew. Now I need end behavior, cross touch, and weather graph. So, guys, on the side here, end behavior. Let me just abbreviate here. Answer these 2 questions. Make x get large. That's my first question of this function. I call it p of x. And all that depends upon the first term. Guys, the first term is easily seen here. You're looking at 4x cubed. That will determine the end behavior. Replace x by some large number. Cube it, gets larger. Times 4 gets even larger. Response? Positive infinity. It's getting really large. On the other end, written like this, x is approaching negative infinity of this function. You're replacing x by a negative number. What happens if you replace x by a negative number? Then you cube it. Does it give you a negative? Times 4, is that still a negative altogether?
Yeah.
Negative infinity. That tells me right quickly in terms of graphing, as I go out to the right, positive infinity, on that end, it's doing this. That's here, guys, it's doing this on this end. As x is approaching negative infinity, down here on this end, it is dropping. Done. Now, can anyone tell me right quickly the cross touch and what we finished? What should be happening at -1 based on what you see up here? In fact, are all the outside exponents odd? It's going to cross out everything. So that means it's going to cross over here. And by the way, I need that y-intercept, if I can find it right quickly. Guys, what is my y-intercept? I better be asking for it too.
0.
It's not 0, is it?
No.
Yeah, I'm going to find p of 0. Well, plug in 0. And I think I heard how much? 1? I think it was 1. So it's up here, just in case I need it, right here. Now let's get that crossing done. It's going to cross over. It may go a little higher than 1 and come back and pick it up. Who knows? It's going to cross again at 1/4. It's going to come down. How far down it comes, I don't know, but it's going to come back up and cross again. And there's your sketch. Done. You can't, how can you not, geez, please don't miss one of these. Find the zeros and sketch it for me. Find the zeros and sketch it for me. Okay, easily done. My last one here in this part here, part B, looks like this. I brought in this one. I think it's also on a handout that maybe you guys have already, but we'll find it here. Here we go. P of x is equal to 2x cubed plus 11x squared, subtract 7x, subtract 6. I stuck with, again, 3 zeros. I'm looking for 3 zeros. Back here, we found 3 zeros. Guys, I noticed that last one that I just finished up, we grouped in an attempt to do the problem. I don't think grouping is going to help me on this one. That needs some help. I gotta find the zeros first. Or I could do the end behavior since we're gonna sketch it. I could go ahead and get the end behavior out of the way, and then find the zeros. Guys, let's get the end behavior out of the way right now. End behavior.
2x cubed.
There you go. You're gonna look at that first term, which is easily seen. And it's 2x cubed. Put the 2 in there. That's my first term. And then, of course, we're going to answer these questions. Find the limit as you make x get large of that. And on the other end, limit as x is approaching negative infinity of this. And it all depends on 2x cubed. Go to 2x cubed, replace x by a large number. That's what it says. X is approaching infinity. Replace x by maybe a large number. Cube it gets larger, times 2 gets larger. Not exciting. Infinity. Now replace it by a negative infinity. Raise it to the cube. A negative number. It's going to be a negative times 2. Still negative. Negative infinity. Now, at least that tells me on the ends what's happening. Woo! By the way, before I leave mine, I don't think I've shown you one tonight where the end could be rising on both ends, have I? Did we look at one tonight where it could be rising on both ends?
And, 4 o'clock.
Yeah, at 4 o'clock session I may have. It could happen like that, it could be rising on both ends. This one's dropping on one end and rising on the other. At least that's that. Now guys, I need my zeros.
Grouping.
Nope, that's why I brought this one in today, grouping. That was a grouping problem, which is beautiful. This one will not group. And you've seen what I'm doing tonight. I need those zeros to place on the x-axis, my x-intercepts, or I can't graph this thing. I need the zeros. How many zeros should I expect? 3. The degree is 3. I get 3. Where are they? I can't graph this thing unless I know where the zeros are. Yes.
Should we do the synthetic?
Okay, now when you say synthetic, you saw me doing a little bit of something called synthetic last week. You're saying, Professor, I need to maybe guess at a 0, and I'll block it off on the side there. And then you use something called synthetic to see if it works. Now guys, this is beautiful. What number are you going to sit there on your exam next Wednesday and at random just pull out numbers out of the air, and all of a sudden you look up at the clock and it's time to go? And you have not found a number yet chosen for out of the air that worked. But maybe there's a student in class that can tell me on this particular one here, Professor, try, and you might be able to tell me a number to try, and it may work. Does anyone have an idea of what one number of the 3 that I'm searching for might be out there? I see a hand going up, yes.
It would be 2, right?
You wanna try 2? I'm gonna try 2. You said 2. I hope. Now, how we're gonna do it, I'm gonna list my coefficients and my constant, no x's, just my numbers. It's called synthetic substitution or synthetic division. And it looks like that. Much easier than plugging in the number. I'm not gonna plug in that 2 he gave me in the original like I usually do. That's too demanding on us. We're gonna do it more simple here. The 2, what happens with the synthetic, you always start with a 0 underneath the first term. The process is easy. Add them up in that column, you get a 2.
And then you multiply by 2.
You multiply his 2 times 2, you get a 4. You add those up in that column, that's 15.
30.
2 times 15, 30. That's my next entry. Add those up, I think it's 23. 2 times 23 is 46.
46.
Add those up, you get,
40.
please tell me, what do you think I was hoping to get if 2 was one of the 3 zeros I'm searching for?
0.
A 0. I got 40. Now, I will tell you, if we did this correctly here, there is a benefit there. It's not one of the 3 zeros I'm searching for. Guys, if a student says, Professor, I would prefer to go directly up here and put in 2 for these like we usually do. directly plug in.
Why
If you
is it
did,
six?
guess what you'll get for an answer?
Can I try again?
Guess what you'll get for the answer if you had done it directly just by plugging in 2 up there?
Negative.
You'll get 40. Probably didn't know that in all your math courses you've seen. You can do all your substitution now in these polynomial functions by synthetic. And they call that last number there the remainder. The remainder is 40. That's the same answer you would get if you were plugging in 2 directly. So there is a benefit. And before I take a question here, he has given me that when x is 2, Professor, the y is 40. That's a point on this graph. Out to what 40 is on this graph. I don't have the graph drawn yet. It's on there. Beautiful. Now I need maybe just at a guess. Oh, you give me a 2. You still no.
I understand what you're saying.
Oh, yes.
I'm guessing we should try a 1.
Let's try 1.
Yeah.
Here we go. Erase this. He said, Professor, try a 1. And I'll ask her shortly here why she chose 1. And we'll go through the process again. Same numbers, guys, from the function. 0, always. First.
It works.
Add them up. I heard someone say it works.
Spoil
2,
it.
2, 13. Is that 13? 13, 6. 6, oh, look at that. One of the 3 zeros is 1. Now, before I show students to do a good discussion on this, why did you choose 1?
Because I tried.
You tried it.
Trial and error. Yeah.
Trial and error, that's it, trial and error, and you found it to work. Beautiful. Now, 2 zeros are missing. What you could do, you could say, well, Professor, after she found 1 for us, could I now test again on those remaining numbers, a different maybe number for a 0, could I test another one? Now, does anyone, I don't know, maybe someone has in mind another one that you think might work, and I'll test it stacked up with her answer that worked, and stack these up like this. Yes, what do you think? I'm trying -1. Here we go. -1. Okay, 0 always here. Add them up and get 2. Multiply these 2 together, I think you get what, -2? That's my math here. Do I get 11? And that's a -11. And will that give me a 0? I want a 0 on the end of this. It's not gonna give me a 0. So -1 I know is not one of the 3 zeros. Does anyone have another one? Test here. And after I show you something here, you're going to say, Professor, really, you made us sit there and think about numbers that might be zeros. And take your time, Professor. And after I show you the little shortcut, you'll say, no. Are you kidding? Does anyone have another choice? Yes.
-6.
Olivia, how much?
-6.
-6. Geez, okay, here goes. 0. Of course, you're gonna get a 2. 2 times root of -6 is a -12. You'll get a 1. The -6 times 1, look at that. Olivia. Thank you. I have 1 more 0 missing. I will stack it up. Use those remaining numbers, what you're allowed to do, as soon as you find a 0, you're allowed to stack it up and find others. Don't have to go back to the original. Does anyone have in mind, I thought I saw a hand going up, what might be the last 0? What do you
I
think?
have a question.
Go ahead.
Why does it say -12? How does that work? How do you get to -12?
This times this,
Oh, you gotta multiply.
isn't it? Oh, yeah, -12.
Okay, thank you.
But now, does anyone have an idea of what the last one might be? And I'll put it in there. We'll check it. If I get a 0 on the end, we're finished. We have the 3 zeros. Here we go. Yes.
Is it negative 1/2?
Negative 1/2. Hang on. Here goes. Okay, here goes my process. 0. Add them up to get a 2. Now she says negative 1/2. Guys, if I multiply these two together, please tell me, is that negative 1? Goes here. 0. Oh, oh, oh. I now have my 3 zeros. Listed as, let's go -6, negative 1/2, and finally a 1. Make sure I copy those down right there. Now you know and I know. Next Wednesday. And I give you one of these problems. Look at what this program is on the board right now. I'll probably have at least an X in the fifth. We're going to be searching for 5 zeros. At a minimum. Sometimes I give X to the 6. This one had X cubed, only 3 answers. And we finally, through this thing called synthetic, just started testing by trial and error, and we got it. Now, let me point out one thing. We'll take a break here shortly. Can anyone tell me, these will be my x-intercepts. I'm gonna graph this thing. Before I graph it, I've got the end behavior waiting for me. Those are my zeros, I had to find them. Can anyone tell me before I jump in and graph it? And be very, very clever for me.
Y-intercept?
What's that?
Y-intercept?
No, we're gonna find that later. First, I want this. Anyone tell me now, what would this right here look like? This one looks like this in factored form. I want this one in factored form, and you gotta be clever. I got the zeros staring at me. So you gotta start putting little pieces together like a puzzle, and tell me now what factors were involved, and start me out.
It's gonna be 2x plus 1.
Oh, now hang on. 2x plus 1, she's telling me, Professor, if you set that 2x plus 1 equal to 0 on the side and solve it, you'll get that. Fix it right next to this. Tell me another one.
X plus 6.
Got it. Set that equal to 0, solve it, you get -6. And the last one has to be?
X minus 1?
Look at that. There's that purple factor. You go across the street to those kids and ask them to factor this. Here it is factored. True? It's factored. Now I'd like to see the graph, and then we'll take a break. I'd like to see the graph of it. Now, to step back just a second. Oh boy. Yeah, I'm ready. Let's sketch it. Seems like all these tonight, for some reason, I had x cubed. Darn it. I didn't bring in an x to the 4th. A lot of x cubes here tonight. We'll sketch it. We guys got the end behavior, got the zeros. I'll pick up that y-intercept that a student was concerned about earlier, and we'll graph it. Go for it.
You say you will show the another way, not synthetic, but another way of finding zeros?
Without synthetic.
Yeah. You say that you will show.
What you'd have to do, I'm showing the entire process yet until after the break. You'd have to say, well, guess one, Professor. Right now, at this point, without this, called synthetic, you'd have to directly plug in 1 all the way across here in the original and hope to get 0. To test -6, look at what a mess this would be. -6, you have to directly replace x by -6, plug in into the original and hope you get 0. I don't want to cube -6. So that's why we're using synthetic. Oh, I see hands going up even before I get to the grid. I love this. Go for it.
No, I think they recommend, and that's what I also understood, that they use it. I also thought they just say you can show us like a different way.
Oh yeah, I got you. Something else is coming up. something else is coming up. I'm not finished until after the break. I'm going to grab this thing, then we'll take a break, and I'll show you more of what's coming up. Yeah, yes?
So regarding the synthetic division, how would you guess the next number?
You mean the first number? The test number? Oh, that's what I gotta show you. That's after the break. That's what I was gonna ask. I was gonna ask my students here. Of all the numbers in the universe, yeah, I understand one's a small number. Yeah, the student said test 1, we lucked out here, 1 worked. Then all of a sudden, a student gave me -6. Who on earth would think to test -6? Who gave me -6? Who said -6? Olivia. What made you say -6 and not -7? Or maybe she's doing something there that we're not aware of yet. Okay?
Maybe because -6 can work because of the finding the y-intercept.
Nope, has nothing to do with y-intercept. You're gonna find, I'm gonna show you what it has to do with. I think that's his question. Where on earth do those test numbers go, Professor? If I were testing on my test next Wednesday, I may not test -6. Aiden may walk out of here crying. So I'll say, Aiden, did you get all 3 zeros? Professor, I didn't get any. And all of a sudden, I said, turn your scratch paper in. He's filled that scratch paper up with numbers, and every number he tested did not work. And all of a sudden, his hours are up. And all of a sudden, Olivia walks out, she tested -6, and she walks out early. She got like just like that. Where did those numbers come from? Am I going to just sit there and randomly select? That'll take all your time. You can't. They came from somewhere. I love that question. Where on earth did they come from? Yes.
So, well, if you have 1, then you can guess -6 by like doing it in like the reverse way. So, like, I don't know if that makes sense. So basically, just going backwards instead of going from left to right, just going from right to left.
Sorta. Not quite there, but
Does it make
sort.
sense?
I know what you're saying, but sorta. That's the question right now. My students gave those to me, but where on earth, if I were a student, say, where'd you get -6? Olivia, where did you get -6? And then one of my students said test 1. I tested it, it worked. -6 worked. You're saying, are those students just smarter than I am? I've probably been testing 10, -8, 3/4. They wouldn't work. That's where I've got to show you after the break, where do those numbers come from first? Let's get the sketch done. Let's get the sketch done first. Then I'll take questions. We're going to take a break. What a class. Now guys, the sketch, and we'll do it fairly quickly. Real quickly here. Here we go. Here. Okay, my zeros, let's get those zeros out of the way. -6, way down here. There's an x-intercept. -1/2, right in here. I'll mark this, I can see it, -1/2. 1, here. By the way, as I'm picking up the intercept, can anyone look at this real quick and tell me where's the y-intercept?
It's -6.
-6.
Yeah.
Replace the x with 0. So that would help if I could do this. I'll go down here, mark it. There's the y-intercept. Now let's graph it. In behavior, on the right, as x gets large, positive, it's going to be a positive, so it's doing this, which we would expect. And out here, we determine on this end, it's doing this. That's the end behavior. Now touch cross, we lucked out, I think. Are all of the outside exponents odd? So it's going to cross here. How far up it goes, I don't know. Hang on. It's got to come back though and pick up that. It's got to slide down. It's going to cross again. And finally, it may go down a little further and come back up and pick up that y-intercept. It may. And then come back up and connect with 1. There's your graph. Make sense? Strange looking graph. Passes the vertical line test. There's your graph. End behavior, cross. No touching on this one. Cross up at each one of the zeros. Now, we're going to take a break. As soon as you get back, wait till you see where are